Hello, we are doing 8 and 4, lesson 10, critical look at proportional relationships. So we are going to revisit proportional relationships from 7th grade, and we're going to relearn them, and we're going to see how they connect into what we've been learning with linear equations. So let's get to it. Let's get to it and start learning. Let's go to, okay, so what is a proportional relationship? When we talk about proportional relationships, we need to understand what that means. And what we did, again, is we learned this in 7th grade. I'm going to remind you. We learned some of the features of proportional relationships. We're going to review them over this lesson and the next lesson. But basically, they are equations that can be written. There are equations that can be written in the form, and we're going to go over lots of examples today. Y equals C, a constant, times X. Okay, so Y equals C, this is a constant, times X. Another key point of proportional relationships are the point 0, 0 always makes a proportional relationship true. Okay, so we've talked a little bit about this. A point being 0, 0. Remember, when we represent things using points, the first point is always X, and the second point is always Y. So in a relationship like Y equals C times X, if I put a 0 in for Y and a 0 in for X, it will always be true. And I think you can maybe see why that's true, because a constant times 0 will always equal 0. But this is just kind of a detail, and we're not going to harp on this too much today, but this is just a key point that we should have in the back of our minds. This is the big thing that we're going to be dealing with today. Learning how to find this constant C and how to build tables of information based on various proportional relationships. So let's make what I'm talking about tangible. Let's talk about making it tangible with some real world examples. So let's talk about in Go Fish. So when we play Go Fish, each player starts with 5 cards. So, you know, I have 5 cards in my hand at the beginning of Go Fish. And if I'm playing with 2 other players, you know, each one of them has 5 cards. Each, right? So if we have 3 players, we have 15 cards to start the game. If we have 2 players, we would just have a total of 10 cards. So I think you can kind of see where this is going. So what we want to do is we want to figure out how many cards do I have if there's, you know, a certain number of players. So we're going to see, this is, see if we can understand this proportional relationship. And what we're going to do is we're going to build a table. So when we deal with proportional relationships, we're going to talk about tables of information, and we're going to talk about equations. And these two things are kind of the same thing, but we can go back and forth between the equation and the tables of information, and you'll see how we do that as we go forward. So in this case, what I want to do is I want to build a proportional relationship between my players and my cards. The players and the cards. Okay. Let's have one column be the number of players. And in the other column, we'll have the number of cards. Okay. So we've already decided if we have one player, we have 5 cards. And here we see if we have 2 players, we have 10 cards. If we have 3 players, we have 15 cards. If we have 4, we have, right, I heard someone say 20 cards. Now this is our table. This is our table of information. And when we're dealing with a proportional relationship, we can always take our table and we can create an equation. Now, when we build an equation, we are always going to use x. Well, I don't know if your teacher is going to do this, but the way I like to do it is the first column is always x. And the second column is always y. And so we're going to write an equation, a proportional relationship that connects the number of players to the number of cards. So what we want to do, remember what we said, we want our equations are always going to look like y equals c times x. Always. And that's in a proportional relationship. So we have to think about what do we have to do to x? What do we have to multiply our x by? So the question is, what do we multiply x by to get y? And we can ask that about any column. To get from here to here, we multiply by what? To get from 2 to 10, we multiply by what? 3 times what is 5, or 15. And for you sitting at home listening, you probably have already figured out that it's times 5. Times 5. Times 5. Times 5. So if I had 10 players, we can simply say we'd have 50 cards. So the more general form of this table is the equation. And so our answer is what? Our answer is, what is C? What is C? C must be 5. So I can write y equals 5 times x. And this is my generalized equation. This is my general equation for the proportional relationship, where x equals the number of players and y equals the number of cards. See how that works? And so I can ask a lot of questions about using y equals 5x. I can answer questions like, well, if I have 10 players, how many cards do I have? Or if I have 52 cards, what is the number of players, the maximum number of players I can have? Think about how you might answer that. We're not going to answer that question here, but I think that you might know how to do it. Let's go on. Let's move on and let's do another example. Now this one is one that you should be able to figure out based on what we just did. And what I want you to do is answer these questions. You know that cows have 4 legs. You know what? Here's a cow. Is that a cow? Or is that a pig? Not sure what that is. I think that's a cow. You can kind of see. Actually, you can't tell how many legs he has here. Let's see. Happy Cat. Happy Cat has 4 legs. Let's do that. Let's use Happy Cat. Cats have 4 legs. How many legs are there on 5 cats? And how many legs are on 45 cats? And now what we want to do here is we want a table. And here we're going to have number of cats. And here we're going to have number of legs. We want the general formula. You know, y equals cx, but, you know, what is c? Find c. You want y equals, you want to, you know, I want you to find c. And then I want you to answer question c. This is b. And this is kind of a. Okay, so why don't you pause and hold, give it a try. I think you could probably figure this out, but I want you to fill this in. Okay, I'm assuming you're back. I'm assuming you've tried this. So let's see. The number of legs on one cat is 4. The number of legs on 2 cats is 8. 3 cats, 12. 4 cats, 16. 5 is 20. So the question is what do you have to multiply this first thing by to get to the second one? And it's times 4. Times 4. Times 4. Every single one of these is times 4. So our constant is 4. This is our constant, our multiplier. So our formula then is y equals 4x. Okay? And again, this first thing is x, and the second column is y. That's the way we like to lay it out. So 4 times x, which this is our x column, 4 times x is y. So if I have an x here, this is 4x. So y is 4x. Okay. All right, so how many legs are there on 45 cats? Well, the cats is x. So I would substitute in, 45 for x. And I'd say, well, y, the number of legs, equals 4 times 45, which equals 180 legs. Legs on 4 cats. So hopefully this is something that's relatively straightforward, but we can get more powerful with this. So let's look at the next question. Now, in this question, I'm telling you that I am going to, instead of talking about, cards in hands or cats and legs, we are going to walk at a constant speed around a track. So we're going to walk around this track, and we're going to go, 1 time round, 2 times round, 3 times round, 4 times round, and we're going to go at a constant rate. And so I'm telling you, this is going to be a proportional relationship. When you walk at a constant speed, the distance is represented by a proportional relationship. Well, if you walk at a constant speed and you start at 0, when you start at the beginning, if you start at the beginning, if you start at 0 and you go at a constant speed, then the distance is represented by a proportional relationship. So what I want to do is I want to fill this thing in. I'm telling you that the laps is going to be x and the minutes is going to be y. So I'm going to come down here and I'm going to put laps down here. I'm going to put 7 laps down here because I'm going to want to fill in 6, 5, 4, 3, 2, and 1. So 7 gets me 21. And I want to know how far these other laps, I want to complete this chart. So let's see if you can complete this chart. And I think your key is going to be figuring out what that constant is. So I'm going to have you pause and try. This is kind of homework help too, because you have questions like this on your homework. So pause and try this. This is a little bit trickier, but the first thing I want you to do is find that C value. Okay, now I assume that you're back. So the answer is to get from here to here, it's always going to be a constant value, right? So to get from 7 to 21, that's times 3. So all of these are going to need to be times 3. And so 1 lap takes 3 minutes, 2 laps is 6, 3 is 9, 4 is 12, 5 is 15, 6 is 18. Now we want to write the equation. So the equation of a proportional relationship is y equals c times x. Well, that c is this multiplier number. So our formula is y equals 3x, where x is our laps and y is our minutes. Now we can use this formula to answer difficult questions. How far could I walk in 100 minutes at this same rate? Well, our minutes are what? Our minutes are y. So the question is, if I put 100 down here in the y column, what is our x? What is our x? So we're going to use our formula here. And we know that we can put 100 in for y. Any one of these lines, maybe I didn't explicitly say this earlier, but any one of these lines will make the equation true. So if I plug in 3 and 9, a 3 for x and a 9 for y, it makes it true. So similarly, if I don't know what my laps are, I don't know what my x is, and I know what my y is, and I know what my constant is, I can plug in the known values and find my final value. So what do I know? I know that y is 100. I know my constant is 3. And so I have to find x. Well, we know how to solve these types of equations. We do it like this. 33 1/3 equals x. So if we can go 33 1/3 laps in 100 minutes. Pretty powerful stuff. And it's all based on building the chart, building the formula, and then solving the problem. Okay, let's try another one. Another homework helper. This is my final homework help. So now I'm going to tell you I walk at a constant rate of 4.5 miles per hour. So my hint to you, so this is a different way of asking the question. So C is 4.5. So I want you to create a chart that shows how far I go in 1, 2, 3, 4, and 5 minutes. I want you to write the general formula. And then I want you to tell me how long it takes to travel 26 miles if I walk at this rate. And that's the marathon distance, by the way, just for a little bit of trivia. All right. So I want you to pause and try. I'm going to create a distance chart here. But I want you to pause and try. All right, I assume you're back now. So let's make x be our minutes. Well, I kind of messed this up now, didn't I? Let's make x be our hours. Let's say x, this should be hours. Okay, sorry. This should be hours. Okay, now pause and try. I'll try and fix this up on the video. Okay, so if I go 4.5 miles per hour, my C is 4.5. So there's a couple ways to look at this. If I go 4.5 miles in an hour, then I can go in 1 hour, I go 4.5 miles. Another way to look at it is I know that this column times 4.5 is that column. So I could have said in 1 hour, I just multiply by 4.5 because that's my constant. Does that make sense? So in 2 hours, if I go 4.5 miles in 1 hour, then in 2 hours, I would go 9 miles, which is 2 times 4.5. In 3 hours, I'd go 13.5. In 4 hours, I'd go 18. And in 5 hours, I would go 22.5. All of these are times 4.5, times 4.5. So my general formula then, just like everything we've done so far, is y equals cx. Well, our c is 4.5. So our formula is y equals 4.5 times x. So how long would it take to travel 26 miles? So does the 26 go in the left column or the right column? Well, you tell me. The right column is miles, so there's 26. And so that's our y. So we're going to put 26 in for y, not x. So we'll say 26 equals 4.5 times x. And to solve this, we need to divide both sides by 4.5. We get x is equal to, I'm using my calculator, just letting you know, is equal to about 5.78. About. It's about. This is rounded. So x, it'll take me 5.78, what? X is in hours. Hours to walk a marathon. That deserves a happy cat. Okay, hopefully this was a useful lesson. Remember, these proportional relationships are ones where we have where we start at 0. So if we go 0 hours, we would go 0 miles. There are going to be these other kind of linear equations that aren't proportional as we move forward. So got to keep that in mind. But again, proportional relationships, the whole key, y equals c times x. Find that c, build a formula, and you can answer any question about that relationship. So with that said, we'll come back to me. Boom, boom, boom. That was 8M4 lesson 10. Critical look at proportional relationships. You're welcome. We'll be back tomorrow with 8M4 lesson 10. Keep strong. Strong math. Those who know math will rule the world. Or at least get pretty good jobs and be well respected by their coworkers. All right, take it easy. Bye.